All right, guys, Mr. Jet here. Algebra 2, we're going to start looking at our next unit today, which is trigonometry. This is really going to allow us to talk about the relationship between an angle and a side within triangles. So you guys did a lot of this in geometry already, but we're going to kind of use what you did in geometry and then take that just one step further. So first thing I want you to do is go ahead and try this problem here. So rationalize the denominator. Once you're done, go ahead and unpause your video and the answer will be there. All right, here's what you should have got. Remember, the way we rationalize the denominator is multiply it by itself, because the square root of 3 times the square root of 3 just equals 3. Do the same thing to the top, so we get 7 root 3 over 3. Okay, so what we're going to do here is we're going to look at different ratios that we can use with trig. So we've done sine, cosine, and tangent before. Now today we're going to look at these also called cosecant, secant, and cotangent. So if you remember, we label a triangle in 3 different ways. We label it as adjacent, opposite, and hypotenuse. Okay, so remember, the hypotenuse is never going to change. The hypotenuse is just going to be whatever side is opposite of that right angle. It's going to be our longest side. Now, the adjacent and the opposite sides depend on which angle we're looking at. So in this case here, this is the angle that we're looking at. This is our theta. Okay, this term here is theta. That's just used to represent a missing angle. Just like x represents a missing side, theta represents a missing angle. And so since my angle that we're talking about is here, we're going to label this opposite and adjacent. Well, this side here is closer to this angle. It's adjacent to this angle. And this side over here is opposite. So we're going to label this side here as my opposite. This side here is my adjacent. Over here, the only thing that changes, that are the same triangles, now we're using this as our angle that we're referencing. So now this over here becomes my opposite. This here becomes my adjacent. Okay, so we have these ratios, these different trig ratios, sine, cosine, and tangent. So if you remember back to geometry, our ratio for sine, and if you guys remember, we use this SOHCAHTOA here to help us remember these. Okay, so we say sine, so S-I-N represents sine, of our angle, theta, equals, and so the sine is so opposite side over the hypotenuse. Cosine, our abbreviation for cosine is COS, of our angle theta is adjacent over hypotenuse. And then tangent, our abbreviation for tangent is TAN, of our angle theta equals TOA, so opposite over adjacent. So this is always going to be an angle, whatever that theta is. So it'd either be missing, and we'll put theta there. And then these are always going to be sides. Okay. Now we have these new ones down here. We have cosecant, secant, and cotangent. And so really all these are reciprocals of what you have up here. So cosecant goes with sine, secant goes with cosine, and cotangent goes with tangent. Cotangent's easy because it sounds the same. These here get a little bit confusing because some people might think co goes with co, but actually it's opposite. Sine goes with cosecant, cosine goes with secant. And so again, all they are is they're the reciprocal. So it's flipped. So cosecant, okay, so we have CSC is the abbreviation for cosecant of our angle theta, and it's just the reciprocal of this. So now it's going to be hypotenuse over opposite. Secant, our abbreviation for secant is SEC of theta, just the reciprocal. So it's the hypotenuse over the adjacent. And then cotangent, COT of theta, reciprocal, so adjacent over opposite. Okay, and so again, the hypotenuse and the opposite, the adjacent, those are sides. Theta is our angle. So we're going to be setting up these equations to help us find missing sides or missing pieces. So this page here is just a summary of what we just talked about. Okay, so remember sine is OH, opposite over hypotenuse. So S sine goes with OH, opposite over hypotenuse. C cosine, AH, T tangent, OA. The other way that you can think about cosecant, secant, and cotangent, again, we just talked about the reciprocal. So we can say cosecant is hypotenuse over opposite, or you can also think about it as 1 over sine. Because if sine of theta, we make the reciprocal of that, we move to the bottom. Same thing with these other two. Okay, it's just another way that we can think of and write cosecant, secant, and cotangent. All right, so let's look at our first example here. So first thing that we need to do here is we need to go ahead and look at our triangle, and we need to label our sides. So here's our theta. Here's the angle that we're using. Now, remember, I always start with the hypotenuse, so I don't get that confused. So here's my right angle. Opposite of my right angle is my hypotenuse. Then I have across from my angle here, this is my opposite, and then this is going to be my adjacent. Now, the problem with this picture here is we're missing a side. We don't have the adjacent side. And so what we're going to have to do first, we're going to have to find that adjacent side so that we can use it with any of these trig ratios over here that needs the adjacent side. So right triangles, missing a side, all we need to do is Pythagorean theorem. So 3 squared plus the adjacent side squared equals 6 squared. So we get 9 plus x squared equals 36. Get x squared equals 27. We square root that. We get x equals square root of 27. And then we need to simplify that. So 9 goes into 27, so I'm going to pull out a 3, because this is the same thing as square root of 9 times 3. So it simplifies as 3 root 3. So that tells me my adjacent side here is 3 root 3. Now that I know all three of those sides, I can simply plug that in to each of my trig ratios over here. So remember, we're using so, ka, ta. So for sine, we have opposite over hypotenuse. So I'm taking the opposite side, 3, over the hypotenuse, 6. All I need to do then is simplify that to 1/2. So in this case, sine of theta, sine of this angle right here, equals 1/2. Cosine, we have adjacent over hypotenuse. So I have 3 root 3 over 6. Again, we're going to simplify that, and we're just going to get root 3 over 2. Tangent, opposite over adjacent. So I get 3 over 3 root 3. All right, here's going back to what we did on our warm-up today. We need to rationalize that denominator. So first thing I'm going to do is I'm going to cancel out these 3's. And so I just get 1 over root 3. And then I'm going to rationalize that. So I'm going to multiply top and bottom by root 3, which is going to give me root 3 over 3. Now for these next ones, all we have to do is take those answers and flip them, because it's just a reciprocal. So cosecant goes with sine. So I'm going to do the reciprocal of 1/2, which is 2. Secant goes with cosine. So I'm just going to take the reciprocal here. I'm going to get 2 over root 3. Again, we need to rationalize that. So multiply top and bottom by root 3. We get 2 root 3 over 3. And finally, cotangent. Cotangent goes with tangent. Now, I could do the reciprocal of my answer here, but then I would have to rationalize the denominator. So what I'm actually going to do is I'm actually going to take this here and then do the reciprocal of 1 over root 3. When I do the reciprocal of that, I just get root 3 over 1, or just root 3, and then I don't have to do any rationalizing. Okay, so I have sine of theta equals 1/2, cosine of theta equals root 3 over 2, and so on. All right, let's do one more example. So the only difference with this problem is we don't have our triangle given to us. So the first thing that I would do on this one here is I would draw in your triangle. It doesn't matter where you put things, you just have to put them in the correct spot as far as opposite, adjacent, and hypotenuse. So I'm going to call this my theta here. And so it tells us that cosecant of theta equals 10 over 7. So what we want to think about here is, remember cosecant is the reciprocal of sine. And we know sine of theta equals opposite over hypotenuse. So that tells us cosecant of theta is hypotenuse over opposite. And so what that tells me is that 10 is the hypotenuse and 7 is the opposite side. So I'm going to label my triangle 10, opposite side is 7. And so then what it's asking us to do is define cosine. So cosine of theta equals adjacent over hypotenuse. So then the only thing we're missing here is our adjacent side here. This is our opposite, this is our hypotenuse, this is our adjacent. So again, we're going to have to use Pythagorean theorem. So 7 squared plus x squared is 10 squared. So that gives me 49 plus x squared equals 100. So x equals square root of 51. And so cosine is going to be cosine of theta equals adjacent, which we just said is root 51, over hypotenuse, which we said is 10. There's no simplifying that needs to be done there, and so that is my final answer. So the only difference here is we just have to draw the triangle, use what's given to us to then find what they're asking for. All right, I want you guys to do these two examples here, two exact same examples we just did. Pause your video. Once you're done, unpause it, and I'll have the answers there. All right, here are your answers. Check through those. Make sure you're using Pythagorean theorem on both of these to find that missing side, and then make sure you're rationalizing and simplifying where needed.